This is a cyclic quadrilateral, a four-sided polygon inside a circle where the four corners lie on the circumference of the circle. In this video, we're going to prove the following circle theorem, that the opposite angles in a cyclic quadrilateral are supplementary, or that they add up to 180 degrees. This means that the opposite angles, blue and purple, add up to 180 degrees and are therefore supplementary, and that the opposite angles, yellow and orange, are supplementary. They add up to 180 degrees. We're going to achieve this by making use of the diagonal lines in the quadrilateral, together with another circle theorem, which I covered recently in another video, where I showed that the angles in the same segment are equal. This circle theorem will be used to easily prove that opposite angles in a cyclic quadrilateral are supplementary. I've provided a link in the description so that you could see how I proved this theory in my previous video. Understanding that theorem and seeing how it's proved will help you better understand this video. Now, the first thing I'm going to do is to highlight the diagonals of the cyclic quadrilateral as well as the left and right sides of it. You can see that this shape fits perfectly onto the quadrilateral. So let's hide the top and bottom sides. Now, if you look at the top and bottom angles, this angle here and this angle, you should see that they are angles in the same segment. But to make this more clear, I'll show you the two segments separated from each other. There's a bottom segment with no angle in it and the top segment with two angles. According to circle theorem, these two angles are exactly the same. So let's give them a label. I'll label them with an A. And let's hide the segment that contains no angles. Now, if you look at the bottom two angles, you should recognize that these two angles are in the same segment. Again, I'll separate the two segments so you can see them clearly. You have the top segment with no angles in it and the bottom segment which has these two angles. I'm going to label these angles B. We can get rid of the segment with no angles in it. And if we bring back the quadrilateral, you can see that we have four angles already labeled, and there are four which we've yet to label. In order to do those, I'm going to highlight the diagonals again, but in a different color, and this time highlighting along with them the top and bottom sides of the quadrilateral. And although things might be a little bit more difficult to see, you should recognize that we have two sets of angles. We have the left and right angles, which are angles in the same segment, because on the right hand side you have a segment with no angles on it, and then you have these two which are in the other segment. Let's highlight the relevant segment, and even though we have this extra segment on this side, these two angles are still in the same segment and there are no angles in this segment. So this angle here and this angle must have the same value. Let's label them with a C. Again, we can get rid of the segment containing no angles. And finally, we only have two more angles to describe. And hopefully by now you can see that these two angles, which is this angle and this angle, are two angles in the same in the same segment. There's a segment containing no angles, and then we have this angle and that angle in the same segment, so they must have the same value. Let's label those with a D. And now we have the quadrilateral with all of the angles marked. Let's get rid of the highlight. So now you can see that the cyclic quadrilateral contains four different angles, A, B, C, and D. I'm going to do a little trick here and visually split the quadrilateral into two large triangles. So we have a large triangle on the bottom left and a large triangle on the top right. What is the sum of all angles in each of these triangles? In the purple triangle, the sum of angles is A plus B plus C plus D. But in the blue triangle, the angles are the same. The sum of angles are A plus B plus C plus D. And we know that the sum of all angles in a triangle is 180 degrees, which means that A plus B plus C plus D, which is the sum of both of these triangles, equals 180 degrees. And now we know that the sum of those angles add up to 180 degrees. Let's take a look at the sum of the opposite angles of the quadrilateral. And you should now see that the sum of opposite angles is A, B, C, and D. If we look at the top left and bottom right, the angles are A, B, C, and D. And if we look at the bottom left and top right, the angles, or the sum of angles, is A, B, C, and D. And this confirms exactly what we were looking for, where the opposite angles, or the sum of the opposite angles, add up to 180 degrees, and therefore opposite angles in a cyclic quadrilateral are supplementary.